right. Well, who knows where everybody is today, but we'll get started anyway, and people will join us if they choose to join us. So good morning to you all. We're going to talk and kind of continue what we've been working with our skyscrapers, only this time we're going to talk about actually how to fabricate them. So this ends up being part of your assignment 203, where we're going to actually unroll the surfaces of your building and create like a paper model that you could glue together. Again, we're not in person, so you're not physically building the model this semester, but you'll have the digital version of it that I'll, of course, grade, and it'll be part of your assignment. The other thing we'll talk about today is 3D printing. And again, because we're not in person, you won't actually do the 3D prints, but I'm going to walk you through the process of getting ready to 3D print and that sort of thing. So I'm going to go ahead and share my screen here, and then we'll get started. So bear with me. Just get a little bit organized. There we go. All right, and I've gone ahead and I pulled up our exercise 217. And like I said up here at the top here, we are going to practice generating the G code, even though we're not going to be creating it, or we're not going to be 3D printing. But I want to walk you through that whole process so you are at least a little bit familiar with what would be involved. So I'm going to go ahead and I'm going to open up my building that I've been working with. So we'll double click on Rhino. And I'm going to go in and open up my, if I can find it, skyscraper fall of 2022. There we go. And let me switch back into my shaded mode like that. And we see my final building right there. So before I move on, I'm going to do a save as so that I have my original. This was part of my rendering part. Now we're going to talk about doing it as the unrolled surface. So I'm going to go ahead and go to File and then Save As. And let's put it into today's folder instead. And I'll go ahead and click on Save. Now, perfect. So when we start to think about this as unrolling, there's a couple problems. The way that I built this, I kind of have these three separate shapes that would be glued together. And that's fine. I could certainly work with it, but I don't need the interiors of these shapes. So let's start to clean it up. I'm going to go ahead and in my layers, I'm going to turn off my floors and my ceilings, because really what I'm working on is just the skin. So we'll turn off the floors, we'll turn off the ceilings, and we'll leave the core on for just a second. And now what I want is I want to kind of trim these out. So I'll take this outer part and I'll type explode. And then I should, and it might be easier to see this in shaded mode here, or excuse me, in ghosted mode. I should be able to take that interior right there, and I should be able to delete that. So delete that piece of the interior. Same thing happens here. I'm going to go ahead and type explode. And I should be able to select that interior surface, and we'll delete that one as well. I can press the delete key on my keyboard if I want, or I can just type DEL or delete to get rid of it. I'm going to take the rest of these pieces and join them back together. So we'll go ahead and type join. Oh, but I should have selected the bottom right there. Type join. Same thing with this side. Join. And then we're going to come up here to the top, and we'll go ahead and join that together as well. And now I can use those two sides as a trim for this part of the building. So let's go ahead and use this as a trim. I'll type in trim, and then I'm going to get rid of the inside so that if we were to zoom in and kind of look around in here, let me switch my view. We haven't gotten to this yet, but just to be able to see this a little bit better. Right? If I'm inside my building, There you go. You can see that it's actually been cut out so that, right, it's hollow inside. There, you can see it down a little bit more. I'm going to do the same thing with this side. I'm going to take, oops, sorry, I still had trim active. I'm going to take this and I'll type trim and I'll get rid of that part as well. So essentially I've made this hollow inside, except for my building core. That's much better when we go to unroll it from its surfaces. So let me step back here for a little bit. There it is. And now I could actually take this, oops, sorry, I still had trim active. I could actually take, had to have another enter there. I could take these three pieces, 1, 2, and 3, and I could join all of those together. Like that. So now they're all one kind of continuous surface. That's excellent. Let's go ahead, since we're here, we don't really need the full elevator shaft. And again, this is why I did a save as, because I'm kind of chopping this up. I'm going to go ahead and take it, and I'm going to type trim and get rid of the elevator shaft in the middle. So let's get rid of these surfaces like that. I'll hit enter to finish. And now I could actually join the top of the elevator core with this building, and that all becomes one. It did change my layers, so let's go back to my layers. Let's right click on the skin layer and say change object layer so that it's back in the gray. I think down here at the very bottom, I need to join that in as well. So let's go ahead and join. And notice up here in my command line, 2 surfaces or polysurfaces joined into one closed polysurface. That's excellent. So we'll go ahead and change it back onto the skin layer, change object layer. There we go. So this is very much ready to do an unroll surface operation. And essentially, what do I mean by an unroll surface? Well, in an unroll surface, essentially what we're doing is we're trying to take all of these pieces and break them out into pieces that we could cut out and glue together to make this particular building. And so in this case, we have a little bit of a sway to it. And so we would need to kind of figure out how that would unroll. So what we'll do in order to do this, and I'll do this with another building example too, so you can see this twice, is I'm going to select the object, and then I'm going to go into a surface, is it curve from curve? Sorry, I always go, where is it? I'm just blanking on it. Where unroll surface would be. I always type it. My mistake. Okay, so I don't know where it is. We'll type unroll SRF. That's unroll surface. And when that happens, it's going to ask me to select curves, text dots, and points on surface to unroll. We don't have any, so that's fine. Do I want to explode it? We'll say yes. Do I want labels? I always say yes to labels because it helps orient where we are. Okay, keep properties, no, that's fine. Let's go ahead and create a new layer for the unroll surface. We'll make that active, and then we'll go ahead and unroll it. When I hit enter, it's going to create a bunch of surfaces that are laid out on the ground. So each of these surfaces now corresponds to a matching number on this whole tower. So now I need to spend some time with all of these surfaces that it just created, these, and kind of arrange them. So let's go ahead, let's move these away from 0, 0 for a second. It's possible that some of these, oops, I got to make sure I take the numbers too. It's possible that I had some surfaces underneath. Yeah, there's some surfaces underneath that I'm going to need. So now it's a matter of starting to line things up and understand where various pieces would go together. So we're looking for similar numbers. So I have a piece here with number 41 on it. So let's move piece 41 to match up to this 41. And some people like to do this in the top view. Sometimes it's easier to see in the top view, and there's nothing wrong with that. Let's go ahead and rotate that so that the two 41s line up. That's not a rotate 3D. It's just a regular rotate. I do want to make sure that I'm precise and snapping right to the endpoint there so that they line up, because they're not necessarily square anymore. So those two 41s line up. Looks like I have a 40 right here. So I can move this one to that point. Then I could rotate so that that goes right there. Looks like I have a 37. I can move that right there. Then we could rotate. Want to make sure we're snapping to the end, right like that. So the two 37s line up. I have a 34. Let's move this. So this is kind of like assembling a box. If you were to cut out the pieces for a box on your paper, I think a lot of people do that in, I think it's 130 that you do that, where you think about how pieces were to unfold. Now we've got a piece down here that has a 32 on it. There's no right or wrong answer. We're just matching up numbers. So let's come to this and let's rotate that. So that lines up there. Now we're looking for a 31. Sometimes you have to look around a little bit. There's a 31. Let's go ahead and move this over here to 31. Rotate. I wonder why those don't line up. I'll have to sort that one out. Let's move this away for a second. And let's keep working here. Let's see. Okay, that's piece 30. So we do have a piece 30 here. Let's try those and see if they match up. All right, so those two are good. Let's move those away. So we start to play out. So this piece 29 would line up with that piece 29, but they don't necessarily match up on the edges because those are twisting surfaces. So even if I were to put it there, right, you can see that there's a gap here, but then it kind of overlaps. So that's not a good connection. However, 28s would be okay. So let's go ahead and rotate the 28s to right there. Oh, I wasn't quite lined up. Let's go ahead and move this like that. So I've got 28, 24. There it is. Let's move this. Well, again, we'll rotate right like that. And let's see here. We've got those. We've got 31 off that side. We've got 16. So let's put this piece together. That's a 16. We'll move this. And again, this is why I do it live, so you can see how I'm kind of working through the process here. Let's go ahead and rotate that. That 13 is pretty easy. Let's move this one there, and we'll rotate to there. 18, also easy. Move. Uh-oh. That didn't quite line up correctly. Means those two aren't, so we need to re-rotate that. And this precision actually matters, because if you're going to think about folding these two lines have to line up on each other, or it won't fold correctly into your final shape. So we've got those. Let's move these away a little bit. Move. All right, and let's continue working with our pieces here. 19, 20, 21, 22. And we've got a piece 9 here. We can move that. Line up right there. There. And we should have a 23 right here. Yep. Move. There's a 23. Rotate. Perfect. So this, oops, not quite perfect. Now, this piece 21 right here lines up right there with that piece 21. But we can't take this probably and move it to right here because we're going to get overlaps along the sides. So it's not quite going to work. So we're going to leave that piece separate. So essentially this piece is separate from this piece. And those fold together to form the two pieces that pop out. Let's work with the remainder of these. Oh, that's our actual shape. Let's see here. We've got (51) and 51. We can move those together. (52) and 252 can be moved together. And if you're ever struggling, you can always jump back to the perspective view where you have the numbers over here to start to sort out what's happening in a particular place. So those pieces that I just put together, the 51, 52, that's the little top that goes on top of this building. So these would be the other pieces that go with it. So let's move those over. And let's take a look here. I'm going to take this and this. We'll move that. This one's easy because it is just straight. Let's rotate it. Right there. So we see those line up, those 5s. We can take the 7s. We can move them up. Right there. We can rotate. All right, so that's that top. And this last piece, it shouldn't have separated out, but this goes right inside our bottom, which is right over here. So we can put that there. Now, as we start to look at this, we have 11 and 31. I don't think we can end up putting those together because actually we could, here we go. We can do something here. So let's take this, let's move it. Sometimes it's a matter of starting to assemble the pieces so you can see. So there is piece 31. We're going to rotate that. So that comes around like that. And unfortunately, that matches up in the center of this. So I'm actually going to move it from the midpoint to the midpoint. There, that's how it should be. But see how these two line up? So if we were going to set this up this way, we ultimately really need to switch these so that they go up at the top, up over in here. So I'm just thinking here. Because 22 would be up there. Did I miss this piece? Yeah, I did. Two. I'm sorry, I didn't see this earlier as being the right move here. So you'll have to bear with me for a second longer. Because the fewer pieces that we can create, the better this is going to be when we ultimately go to put it together, because there's fold lines instead of glue lines. So that's good. This is always going to be its own. So we could just move it into the center here, because that's that little top piece for the, sorry, it's right over here. It's the little top piece for the elevator core. So we've got that one. Now we need to move this one. And actually, we're pretty close on this one. I think we can just move it the way it is. And this, once again, is going to match up. Go to the midpoint right there. Okay, so now, if you start to look at it, we have all of our pieces. And if we were going to cut this out and glue it together, we would fold where these pieces come together. So we'd fold, for example, right there. This would then fold there. These two sides would glue together, and then the whole thing would come into a shape. And that shape ends up being, the building that we have here. So the power of Rhino to be able to unroll these surfaces and then glue it together is really substantial. Now, where you have trouble is if you have a bulge. So if you have curvature that happens in two directions. Remember, mine are what are called ruled surfaces. It's always a straight flat line from one edge to another. If you create your shape with lofts, you will never have trouble. Sometimes if you do a cage edit and you pull out one side to create a bubble, that's where you're going to have issues. So now that I have this laid out, I need to start prepping as a lasercut file. So I'm going to go ahead and create a layer, and we'll call this lasercut. And remember, this doubles up as part of your assignment 203. So the fact that you're doing it here is a good thing. So on lasercut, I'm going to have a sublayer for cut. And that one is going to be red. And I'm going to have a sublayer for engrave. And that engrave layer is going to be blue. So I'll come over here and make it blue. Perfect. So I have a cut and an engrave. I'm going to make the engrave layer active, and then I'm going to duplicate edges. So I'm going to type dupe edge, and I'm going to work all the way around my object. Let's get in here. And it takes a little bit of time to zoom in, zoom out, and select all the way around your object. All right, so I've made it all the way around my object, except for that one little piece there. And I'll go ahead and hit enter. And that then gives me a whole series of lines. And in this case, they're blue. And if I were to turn off my layer here, there's an outline of the pieces necessary to start to build this particular shape. At this point, I'm going to go ahead and just ignore the little top piece, because it's just going to get in the way in its own floating piece. So it doesn't really matter for the overall form. Okay, so now I want to think about where are my fold lines. So let's turn this back on. And once again, I'm going to type dupe edge. And this is where I'm looking for, where would I fold? Well, I'd fold there. I'd fold here. I'd fold here. And I'd fold here. Okay, I don't have any other folds here. Let's come over to this place. Well, this one's kind of interesting. I'm going to fold there. I'm also going to fold right here. I'm not folding here because this is part of the bottom. So I would have a fold that's there. And this piece 38 is going to line up with that piece 38 right there. Then we can come down here. I would be folding there. I would be folding there. I would be folding there. I would also be folding there, there, and there. I'll go ahead and hit enter like that. So if I were to turn off my lines now, we'd have our fold lines. So we'd see where we were going to fold. Now we have to think about where we would cut our object. And so some of these are obvious. And I probably could have taken all the lines except for those fold lines and made them cut lines. Actually, let's do that real quick. And and let's put those on the cut lines layer here. Object layer. Oh, and it looks like I made a mistake and didn't make it red. There it is. So that's good. That would cut out our shape, except for those little pieces right there, which would need to be cut. So let's change those to the cut layer. And this would actually fold together to make my overall shape. Now, the problem with this, and actually this needs to be red, I'm seeing it right now. The problem with this is that there's no way to glue it together. So I could, of course, cut this out and try to glue the edges of the paper together, but that's sometimes really difficult. So what I do is I add a little bit of a tab, like a glue tab, that's going to help me glue this together. So when I do that, I want to think I only need it on one side. I don't need it on both sides. So for example, doing it on the inside of this would probably be a little bit difficult. However, if I were to add a tab out here and out there and maybe there and there, that would work. So what I'm going to do is I'll do an offset. And the offset distance is kind of arbitrary. It's going to be something like about there or so. So that when I offset it, there's an offset. And there's an offset. So this edge, when folded, is going to allow it to glue to that edge right there. This edge, when folded, is going to glue it to right there. So we'll repeat, and we'll do it here, and we'll do it here. And actually, I should change my layer because these are going to end up being cut lines. So that lines up to there, that lines up to there. Okay, perfect. Now I need to think about this and this are going to join together. So one of these is going to need an offset. And we're just repeating on opposite sides there. Those would glue. And likewise, this is going to need an offset there. And this is going to need an offset there. This piece would glue to that piece. So I either need an offset here or I need an offset there. Doesn't matter which one you choose. We'll go right there. There it is. That glues up. Perfect. Let's do these as well. Those as well. And since we're here, let's go ahead and do the ends. And we'll do these ends. So this is one of those unfortunate things where I wish I had the physical model because it would make a lot more sense when we went to look at it. So I can now connect these. So again, I'm on the cut layer, and I'm just going to connect those so that that would be cut out. I will connect these so that that would be cut out. Connect that. And if you have a place where it kind of overlaps, that one's actually really close. So we'll just go ahead and do it anyway. But if it overlaps, you can just trim it off. There. And there. Now, I have to keep going up here, but the outermost lines should be cut lines. So let's change these all to cut. And now because of these tabs, I actually need to change these inner lines. So there, there. And those three, they should all be engraved lines now, because I'm folding those where the tabs are. So same thing up here, where I would connect these. And I'm just right-clicking to repeat the last command. In all honesty, okay, that one's going over, so this is where a trim would happen. There it is. And same thing over here. So we go ahead and trim that like that. And again, the inner lines, so there, this one, this one, this one, and that one would all go on the engrave layer. Like that. All right, we're looking pretty good here, though these need to be cut and these need to be cut, because we need to be able to cut our perimeter. I need to draw the lines for the tab over here. And again, this one becomes an engrave layer. So it's just a matter of working your way through your drawing and identifying where the tab should go and where the engrave should go. So now knowing that, these two would become engraves. So we'd have a fold. We're coming into here. This would get trimmed. This one would gain a little line. Like that. Those would all get cut out, and now we're down to just these last two. This and this would go on the engrave layer. And that would get trimmed. Now, does that really matter when you're laser cutting? Probably not. It all probably is about the same when you kind of burn things up in the laser cutter, but we'll go ahead and be accurate and do it correctly. There it is. So now if I were looking at this, let's switch over into the top view. All right, this is ready to be cut out. And if I were to cut it out and glue it together with those little tabs, the end model would become my building. And so it's a really powerful little strategy. What did that take me? A little bit less than 40 minutes to build this out. And now I could build a paper model of what my building massing looks like very easily. So it's a skill that's worth getting used to and kind of getting to the unroll stage like this. This would obviously be our laser cut file. We would scale it down to fit on a laser cutter like we did with the topography. Our purposes are not for that. What I'm asking you for today, and what I will ask you to turn in as part of your assignment 203, is once you get to this phase, you'll go ahead and go to capture, to file, and you'll show me an image of your red and blue laser cut lines like this. That's as far as you need to go. You don't need to actually export the AutoCAD DWG because we're not going in and actually cutting it. So that is, how do you create the unrolled surface on a particular building? Now, the other strategy is that we can, instead of unrolling a surface, we could use a 3D printer to build one of these for us. And a 3D printer works essentially by adding small, thin layers of plastic in a row, right? Thin, tiny layers of practice to build out this overall shape. Some of you are probably already familiar with 3D printers. Some of you may even have 3D printers. If you do, you can absolutely play around with this and build your own shape. Now, there are a couple significant things that have to do with creating a good 3D object. I'm going to go ahead and take this object and bring it over into another drawing. So let me go ahead and go to Edit and then Copy. And then I'm going to open a new Rhino. And then I'll go ahead and go to Edit and then Paste. So let's zoom, extents, there it is. And let's move it over to the origin. So let's take this and let's move it to 0, 0, just for clarity. So I already worked a lot getting ready to do the unrolled surface where I trimmed out the inside of this object. I'm going to go ahead and extend this for a second, even though I normally wouldn't, because I want to show you how we can verify that things are actually working in our object. So in order to 3D print, we need this to be a closed watertight object. So 3D printers don't like open surfaces. They don't like you to have, say, a box like this with an empty side. That doesn't 3D print well, especially if you're trying to print the full box. So what 3D printers like is for you to essentially have created a shell of your object and for that shell to be all joined together. And that makes 3D printing easy. So much like I did earlier for the unrolled surface, I went inside and I trimmed out those inner surfaces where these three pieces were kind of coming together so that it was hollow inside. Then I would come back and I would start to join my object together. So I'd type in join, and those are starting to become a polysurface, right? So now that's part of a polysurface. I did not yet include this top yet, so I could hold down Shift and add that in, join. But what we need is we need a way to determine what isn't joined in yet and what edges aren't going to work nicely in the 3D printing. So we can actually show edges. And if I type in the show edges command, it's going to ask me what surfaces. I want to select all, and I'll hit enter. And then under this edge analysis tool, you see that we can show all edges, or we can show only what is called naked edges. The naked edges are the edges that aren't joined to another surface. So this really helps us to see what's joined. You saw that I joined that object in, the naked edges went away. So if I took this piece, held down Shift and selected this piece, and then type join, what used to be highlighted in pink there is no longer highlighted because it's been joined together. Likewise, if I took this object and that surface on top and joined them together, the naked edge there would go away as well. So ultimately, what I'm looking for is to be able to go through this edge analysis, make sure that when I join everything together, there are no pink edges anymore. I still have pink edges down below here because I haven't joined those together. And notice that when I join this together, all of my naked edges go away, and I get 5 surfaces or polysurfaces joined into one closed polysurface. That's ultimately what we're after. When we have a closed polysurface, that's when our best 3D printing is going to happen. Some of the newer 3D printers will actually accommodate objects that intersect one another. So I could have, say, a box like this, and I could have another box inside of it, like the elevator core, like that. And you could send this to be 3D printed, and that would still work, even though there's 2 objects. These don't have naked edges themselves, but they do intersect, which could be problematic in some 3D printers. The best is when you have objects like this one, where it's a complete object and there are no naked edges at all. Okay, so I now have those ready to work. So the next piece of this is that I need to start doing 2 things. One, this is a NURBS model. So it's designed in Rhino. It's all mathematically driven. 3D printers work from polygonal models, kind of like SketchUp. So this object is going to have to convert from its current state into a mesh in order to do it. So by the way, I should have pointed out along the way that if you get a little bit lost, there is a tutorial here about how do you get a 3D print ready file. So here it is. There's the part about show edges. This is about the mesh, right? It also gives you the scale. I'll come back and reference that scale in a second. So we've got mesh, and so you can go through all of those little bits along the way. So let's look at this in a mesh. So I'm going to select my object, and then I'm going to create a mesh. I'll go to mesh from NURBS object. I could also just type in mesh on the keyboard here. And when I do this, you can see that I have the option to slide between fewer polygons and more polygons. And this is going to determine how smooth your surface is. Because remember, any surface in a mesh is going to be made up of those triangles, kind of like the topography was when we first brought it in. So the advantage here is we can actually use the preview button to take a look at what the triangles look like and how accurate that might be. The higher we do in polygons, the tighter the mesh is going to be, and the more it's going to resemble. The fewer the polygons we use, get all the way down here, right? The less accurate the shape's going to be. In any case, this is fairly accurate regardless of my options. I'm going to go back up to the middle. We'll hit preview. Yeah, that seems about right. And I'll go ahead and say OK. This then gives me a mesh copy of my object. So I have my NURBS object here, and I also have my mesh object right there. I have both. Let's take the poly surface. Let's move it away for a second so you can see them side by side. And there they are. So this is reasonably accurate to what my original is, but it's not quite as smooth, but it'll still 3D print well. Okay, so at this point, I'll take my original object and we can turn that off. I probably should just create a layer for mesh. And this one, we'll call this one a poly surface. And I'll right click and say change object layer. And then we can just turn that one off altogether. So that leaves us with this nice mesh object. Now we need to scale this down so it's appropriate. So two things have to happen. One, we're in inches, and typically our printers are looking for a conversion to millimeters, but we're also at 600 feet tall. Well, if we're going to print it, we need to have some kind of a scale. So this is where I have that little cheat kind of set up here. You have a skyscraper, and if you scaled it to 100 feet equals 3/4 of an inch, right? It would either be 6 inches tall, or in this case, we have a 600-foot tall building, it would be 4.5 inches tall. So I can actually scale this down so that it's 4.5 inches. So let's take my mesh, and we're going to scale it. And I'm going to have to turn on my vertex snap here so I can get the height. If we were struggling, we could also do it in the front view like this. And we could actually just go up a straight 600 feet. Oops. Try that one more time, sorry. All right, let's scale. This is a regular scale, by the way. No, sorry, I have to do it as a reference point. Let me do it one more time. So we're going to do 0, 0 as our starting point. And again, I'm in the front view here, so this is going to be 0, 600 feet. And then we're going to scale that whole thing down. Again, in ortho mode, it's going to be 4.5 inches. So we're going to say 4.5 inches. And there it is. Now it got really, really small. That's to be expected. Let's zoom, selected on it. We can go into perspective here, zoom, selected on it, and there it is. And that's, again, I made it right at the origin because now this is the size that we can 3D print. So it's tiny. But like I said, we're still in inches, so we need to convert to millimeters. So we're going to go ahead and change our units. I'm going to type in units. And we're going to change our model units from inches into millimeters. Now, I have to double check my notes here because there's going to be something that talks about right, we're changing, and it's going to ask us whether we want to scale our model. And we're going to end up saying yes. That's why I have to check my notes on whether that's correct. We're going to say yes to make sure that it scales into millimeters. And there we are. So at this phase, we can go ahead and we can export this mesh so that we could 3D print it. So I'll go ahead and save my Rhino file. We'll go to File and then Save As. And this would be, sorry, we need to get into today's folder. That is not today's folder. I'm just going to call this Fall 2022 Mesh. And we'll save. That's just so we can come back to Rhino. But we only need this object. So if I select it, I'm then going to go to File and then Export Selected. And instead of saving it as a Rhino file, we're going to save it as one of two things. Either a .obj, which is right here, an object file, or a .stl, this one, a stereolithographic file. Either one of those is perfectly fine. I don't care which one you pick. I'm going to go with an obj for right now, and we'll put it into today's folder. This is Fall of 2022. And I'll go ahead and click on Save. We're going to save it as a polygon mesh object. So all of that's fine. We'll go ahead and say OK. And that saves that OBJ file. In terms of turning it in, that OBJ file or the STL file is what I'm going to be looking for your assignment 203. So at this point, you're officially done with what's required. However, I want to talk about how you would actually go about 3D printing it now that you have that particular file. So first off, you need to have a 3D printer. No surprise. Second, you need to know about that 3D printer. When COVID happened, there were two 3D printers at DVC. There was a Type A machine, and there was also a Delta Maker. I believe they have some new ones, but I don't know what the new settings are because I haven't been back to campus to check. So that's something that you can, if you went to campus to try this out, you'd have to ask some questions about it. However, I'm going to assume for a moment, of course it doesn't work, that we will use the Type A machine. And I have a link right here that gives you the step-by-step for the Type A machine. And in order to write what is called gcode, the code necessary to 3D print a file, we're going to use something called Cura. It's available on the school computers. You can also download it for free if you want. We're going to double-click it here and open it up. It is made by the company Utilimaker, who also makes 3D printers, but they make this really nice piece of software to generate the code necessary for 3D printing. So here is the printer bed. What we need is we need to make sure that we're set for a particular type of printer. So if I go to printer, you see that I already have series 1. That's the Type A machine. But what I would do is I would go to Add Printer, and it's looking for a network printer. Obviously, we're not connected to anything, so it's not going to work. So we're just going to add a non-networked printer. And this is where they have a giant list of all kinds of 3D printer manufacturers. And so you'd be looking for your particular 3D printer manufacturer, right? So ours was a Type A machines. There it is. It's a Series 1, 2014. And we go ahead and click on Add. I've already done this, so I'm not going to click on Add again. But that adds the printer into our job here. So under Printer, it'll be checked in the Series 1. At this point, all we have to do is bring in that OBJ file. So I'll go to File and then Open Files. And I'm going to look for that OBJ file, which was the Fall of 22 Skyscraper Mesh OBJ. There it is. And we'll click on Open. And if I did it right, it should show up in our view. Now, it automatically kind of determines where you want or where the object would be. See, there it is. And what would be efficient for printing it. So by laying it down, this is a far more efficient way of printing the object. However, we know that that side isn't quite flat, so we might not want it printed. So we can actually take the object and we can rotate the object. I think if I hold down Shift, I think it jumps. Get it to 90. There it is, 90 degrees. And so that feels a lot better because it's standing up and it's going to print accurately. So we've rotated it after the fact in here. Okay, if I kind of orbit around, we can see our object. All of that looks pretty good, and we're pretty happy. Now, in order to print it, we have to go through settings. And this is, again, dependent on the 3D printer you have. So these settings are specific for the Type A machine. Like I said, we have the Delta Maker settings right here. And if you got a different 3D printer, you'd go through and try out some other options. Okay, but all of that I'm showing in these tutorials will help you get there. So I'm going to go back to the Type A machines, and I'm picking that as my example because it's a little bit less complicated. But we want to go in and we want to adjust some settings. Now, I've already been and I've done this today, but they have some basic recommended settings with not a lot of details on them, or you can go into custom and you can actually go through and modify them. I have screenshots of the modifications that I made, and this is, again, several years old, but when we were printing consistently at DVC, these were what we found were the best settings. So you would go through and you just match up these settings, which I've already done here. You just expand each little section. And once you have everything set, like it is here, you're going to click on this slice button. And when you click on the slice, it's going to build it and generate the code for you. This particular building is going to take 2 hours and 11 minutes to print. It tells me how much material it's going to take. And then I'll click on Save to Disk. And then I would save this. This is going to save a gcode file. So let me add .gcode. And then I'll go ahead and click Save. That piece of information is exactly what you need to take to the 3D printer and actually have it make your file. So there's a little bit of involved in actually doing the 3D print itself. And again, because we're not in person, I don't have the option of doing that for you. I will point out, however, that should you want to go, if you're local and you want to go in and try to 3D print an object, again, not required, you can make an appointment. And I have a link down here at the bottom right here, access to the laser cutters and 3D printers. If you contact Bob Logan, I would send him an email ahead of time. He has some open lab hours on Tuesday, Wednesday, and Friday from 10 to 5, and he can help get you set up so that you could 3D print this. Okay? And he could go through some of these settings if necessary to get you guys set up and running. Again, not required as part of assignment 203, but something I wanted to walk you all the way through. Okay, so that's where I'll stop for today. As you know, class was canceled on Monday. So we'll resume next week on Monday. That being said, there is no mandatory check-in this week because half the days weren't part of the check-in because we weren't here on Monday. So it's not required that you come to check-ins today. We'll resume normal check-ins next week. Okay, and your assignment 203 after this exercise should be kind of wrapping itself up. You should be getting pretty well set on that. You are, of course, welcome to come to check-ins today, even though they're not required. If you have any questions or you want to go over anything specific, that would be my pleasure to help you. All right. So with that, I know it's a little bit late, so I apologize, but we had to get through everything. Let's go ahead and come back at 12:25 for anybody that wants to come to the check-ins, and I'll see you guys all next week. Thanks a lot.